Hey guys, Will here. Welcome back to the channel. Now, as you can see beside me, the PC is pretty much finished being built now. In fact, all we have left to do now is just our leak testing, finishing off the cable management, booting it up, praying that everything works, and installing Windows, and then getting into overclocking and stuff like that. So we're getting down to the pointy end now, and the excitement is definitely building. I'm really happy to see what it looks like all finished. But anyway, moving on, the purpose of this video is to quickly give you a tour of the actual water cooling loop as it's finished, and sort of the reasons why I've laid it out the way I have. Also need to show you the backside where the pump is and everything as well, because I haven't actually shown you any of that in any of the videos so far, and that's pretty intricate how all that's been done. And then finally, I want to show you a method that I've come up with to actually perform a leak test on the system without adding any liquid at all. So this is just a really quick, easy way to, I guess, give yourself a little bit of extra peace of mind that you don't have any leaks in the system before you start adding water. So let's get into it. All right, so getting up nice and close on the system, you can't actually see any of the pump and all that assembly at the moment. I'll show you how all that works in a moment. We'll flip the case around. But what I wanted to show you first is the actual flow path. So this is the flow that comes up out of the radiator. So there is a radiator mounted in the front here. The pump pushes to the radiator. The radiator then pushes through and up this pipe. So we're cooling the GPU first. Goes into the GPU, down through the channels here, back up into our top radiator, which is a 240. The front one is a 360. Back down through our CPU, back out of our CPU, down into our reservoir down here, and then through the reservoir, back up and back down into the pump. So there's a couple little intricacies here which I wanted to just cover. Now, the first thing, and I know a lot of people are probably going to ask this, is why are you cooling the GPU first? Shouldn't you be doing the CPU first? Why have you done it in the order that you're doing? Why isn't the bigger radiator at the top? Why, you know, there's a million questions and there's a lot of opinions about this kind of stuff. But I'm going to explain the reasons why I've done it the way that I've done it. Now, the first thing that people need to understand with water cooling loops is it doesn't really matter what order you actually do things, as long as your reservoir is the last thing before the pump. So what actually happens with coolant inside a system is you end up with all of the liquid being pretty much the same temperature throughout the entire system. What happens is it actually reaches an equilibrium where its ability to dissipate the heat through the radiators matches the amount of heat which is being generated by the components that you're cooling, and the coolant will just sort of settle at that temperature. So obviously if you add more radiators and more cooling efficiency, the overall temperature will reduce. But by changing the flow path and changing the order in which you cool things, you're not really making a whole lot of difference anyway, because all of those components that are being cooled are going to ultimately end up being the same temperature anyway once things are under load. So the only real difference is obviously if you're running a highly GPU intensive game or something like that, and your CPU is basically idle, the CPU temperature is going to come up sooner than it would potentially if you were cooling that first or on a separate loop. But of course, once that temperature does reach the equilibrium, everything's going to be the same temperature anyway. So it really doesn't matter what order you actually lay things out inside the case, as long as the reservoir is the last thing before the pump. So we're going up out of the pump, into our graphics card, up into our 240, down into our CPU, back down into our reservoir, out of the reservoir, back into the pump, from the pump into the 360, and then back up to the graphics card again. So what I've done in here is I've tried to keep the flow path as simple as possible. Now, one thing that I did do is add this little U-bend here, which I think looks really nice. Now, there are a couple of things which are going to be interesting with this, because the liquid's not going to run straight out of the reservoir and straight down to the pump. We're actually going to have to reach a level inside the reservoir above this pipe before the fluid will actually start to flow down into the pump. So we're going to have to add a little bit of extra liquid to actually start the system going. Now, I'm hoping that we won't get any airlocks in there, but I do have a bit of a system on the backside which should hopefully alleviate that problem. Of course, my fill port is up the top here. Now, the reason I've done the fill port here and I haven't run any tubes up into the top is it's always important to have a fill port which isn't part of the actual flow path itself. So you can imagine if the coolant's running through all of this, if you're trying to put a fill port in somewhere where the coolant path is actually flowing, then as soon as you open that up to add more coolant, the liquid's just going to come straight out if the pump's running. By having a fill port which is completely separate to the actual flow path itself, the fluid can be running through the system, and you can just be topping that fluid up as you go without it spurting out and going everywhere. Now, obviously, the more full the system gets, the more risky that becomes, and you don't want to be tilting the system around and doing all that kind of stuff while you're going. But the principle is really simple. Keep the fill port separate, and then you won't have any problems filling the system, or at least it's going to make things a lot easier. So the only thing that we may have an issue with here is just basically bleeding some of the air out. We're going to end up with air sort of trapped in here, I'd imagine. We're probably going to end up with a little bit of air trapped at the top of the CPU block. We're going to end up with air sitting at the top of the radiator here as well, potentially, as well as up here as well, because our ports are on the bottom of this radiator. The air is going to kind of settle at the top, so it's probably going to take a little while to bleed the system, but I don't anticipate having any things like airlocks or anything like that really. The only place we might have a bit of an issue is just in this U-bend here. But anyway, let's flip the case around now and we'll have a look at the bottom portion and how all that's laid out with the pump and everything. Alright, so taking a look in the bottom side of the case. Now, the reason I didn't cover any of this in the hard lining videos and stuff is simply because it's so hard to see what I'm doing in here, but I'll explain exactly how it all works out. So this is obviously the pump just here, which goes out through two 90-degree bends across a tube and into a T-piece here. Now this is a ball valve, which is our drain port. So we've got a plug in the end of it now. We fit a barb there with a drain line to drain the system. And it goes through the T-piece into our 360mm radiator, up through the radiator and out through that line that you can see at the back there. That then comes out the back and goes up into our GPU through there. So that comes through the pass-through here and then up to the graphics card. So the other line that comes back down through there just kinks around and goes into the inlet of the pump. So you can see it kind of has, it comes out, bends 90 degrees towards the front of the case and then bends 180 degrees back towards the pump. And the reason I did it that way is I didn't want to have to put the bends too close to the ends of the pipe because I didn't want to distort the material going in. So that seemed like the most tidy way to do it. So the idea was to keep the pump concealed, keep the drain line concealed, and keep the inside of the case as tidy as possible where it's visible. Okay, so as I mentioned before, this is my drain port here, but we can also use this to test for leaks as well. So the way we're going to do that is remove our end cap here, which is just for safety. This is a ball valve, so when the valve is turned that way, it's completely closed and sealed. When we turn it that way, the valve is open and the coolant would flow out. So normally what we would do to drain the system is we've got our fitting here with a drain tube. We'd simply plug that in. So obviously when that valve is open, as it is right now, the system would drain, the coolant would come out. Obviously you'd remove the top cap on the reservoir as well to let the air in to push the coolant down. But yeah, gravity is basically going to drain most of the system. Because this radiator's got its ports at the bottom, that radiator will mostly drain, about 50% of it would drain. So once we've got our drain line installed, we can actually use this to do an air pressure test on the system. Now, you might be thinking straight away there, whoa, hang on, we don't want to have air pressure inside the system. Now, that is true to an extent. We certainly don't want to be pumping a load of air in here. And the reason why we don't want to create a high pressure environment inside our loop is because with a normal configuration of a pump inside a system, you're not going to be generating a lot of water pressure anyway. When you think about it, all that's happening is the pump is generating pressure as it pushes the water out, but it's also creating a vacuum at the same time where it draws the water in. So all we're really doing is just rotating the coolant around inside the system. So the overall pressure is actually very low outside of the areas where it's being compressed into, say, like the flow path of a water block or something like that. But overall in the system, in terms of where the pipes are and everything, the pressure is very, very low. So we don't need to use a whole lot of air pressure to test the system, but what we can do is just inject a little bit of air and see if it holds that air pressure over time. And the reason why I've designed the system the way I have with the ball valve is actually because it aids with this as well. So when we have a ball valve there, we can actually pump some air into the system, close that valve, walk away overnight, come back the next day and see if there's still air inside that system. So there's a couple of different ways that you can do this. I've seen people make intricate setups with pressure gauges and stuff like that, and I think, to be honest, that's probably a little bit overkill. All you really need to do is just see if it's holding pressure at all. And we're only dealing with a tiny bit of pressure here. So what I decided to do was use the plunger, which I actually used to put coolant into the system, to inject air into the system. We'll seal it off, we'll leave it overnight, and then see if it actually holds that pressure overnight. So what we do is we open up our valve, insert the end into our drain plug, or our drain tube rather, inject some air, and you can see there, it's already pushing back a little bit on there, so it's definitely holding some pressure, and I'm going to put a little bit more than that in there. So seal it off, unplug it again, pull it back, put it back in, open up the valve again, inject some more air, and you can see it's pushing back on the valve there, which tells me that it's definitely holding pressure No question about that at all. So that's a good sign. So we'll hold that down there, close the valve off. Now what I actually did was I left it like that overnight. So came back the next day, and then when you open the valve, and I'll show you this in real time here, you'll hear a little rushing sound come out of the pipe when you open the valve. So you hear that? That's telling you that there's still pressure inside the system. So I left it for 12 hours overnight, came back the next day, and it sounded exactly the same as that did after, you know, just a couple of seconds. So that tells me that the system is definitely holding air pressure. Now we're not talking about a whole lot of air pressure here, but it's enough to tell me that the system is at least not going to have any major leaks in it. So when I do fill it with water, I'm feeling a lot more confident now. So look, I hope that this is something that you've found interesting. Hopefully it's something that you guys can do with your system as well. It's not going to work on every single system. You do need to have a ball valve or something that you can use to seal the system off without the air escaping again. So there you have it, a really simple way to pressure test your system before you fill it up with water. So I hope you found the video interesting and useful. If you have, please do hit that like button, hit the subscribe button as well, and the notification button so you don't miss the next one. Next video after this, we are going to be filling up the system with some distilled water, flushing it all out, making sure we don't have any leaks. Then we'll move on to bleeding and booting up the PC for the first time. So stick around, all the fun stuff's to come. Thanks a lot for watching. Bye.